Hello students, welcome to today's session. In this session, we will see how to solve the signal flow graph if a block diagram is given to us. So if the block diagram is given to us, we can find out the transfer function by using the block diagram reduction method as well as using the signal flow graph. So let's take this first example here. The objective is to find out the ratio between the output and input, that is C by R. So first of all, we have to convert this block diagram into a signal flow graph. So for this, we will have these 5 nodes. So simply we will connect all these nodes to each other with the given gain. So at node 1, the input is R, it will be connected. Then at the output, signal is C. Then the yellow node is connected to red node with gain G1. Then this red node is connected to blue node with gain G2. Then this blue node is connected to this purple node with gain G4. And this G4 is connected, this purple node is actually connected to the gray node with gain 1 because we don't have any gain in between these two nodes. Then the yellow node is connected to gray node with gain G3. The purple node is connected to blue node with gain H1 with a negative sign, and it is a feedback loop. Then this blue node is connected to gray node with gain G5, and the gray node is connected to red node with gain H2 with a negative sign because it's a negative feedback. So likewise, we can convert the block diagram into a signal flow graph. So now we will move further and see how we can solve this signal flow graph. So to solve the signal flow graph and find the transfer function, we have to use the Masson gain formula. And the Masson gain formula is like T is equal to summation of K is equal to 1 to N, where N is the number of forward paths, Pk multiplied by delta K divided by delta. So first of all, we will see how many forward paths are there. So this one is first path P1, that is G1, G2, G4. The second path is P2, that is G1, G2, G5. Then the third path is P3, that is G3. Now we will see how many individual loops are there. So the individual loops, we will have this loop L1 as the individual loop, and then we will have a loop 2 L2 as the individual loop. For L1, the gain is minus G4H1, whereas for the second individual loop L2, the gain is minus G2 G4H2. And then the third loop we are having, that is L3, is equal to minus G2 G5H2. Now we will see pair of non-touching loops. So among L1, L2, L3, we will check which loop is non-touching to each other. We will see the pair. First, we will check between L1 and L2 is that L1, L2 is non-touching. Then we will see L1 and L3 whether L1 and L3 are non-touching or not. And then we will see between L2 to L3 whether those are non-touching loops or not. So there is no non-touching loops. That means all the loops are touching to each other. So if let's say we would have been find the pair of non-touching loops, then again we have to check for the combination of 3 loops, those are non-touching. But as we don't have even a pair of non-touching loops, so we will stop here only. Now we'll see the path factor, that is delta K. So delta 1, first of all, we will find and we'll see what are the paths that are non-touching to P1. So we have found that all the paths are touching to each P1, P2, and P3. So that's why our delta 1 is 1. Similarly, for second path, we will check. So we have seen that all the loops are touching to second forward path. So that's why the delta 2 is 1 minus 0. So that's why delta 2 is 1. Similarly, for path P3, we will see what are the non-touching loops. So we have found that there is only one non-touching loop to this particular path P3. So and that loop is L1. So we have the delta 3 as 1 plus G4 H1. So simply how we can check? We just see what are the nodes in particular forward path, and we will see from each individual loop if any of the loop is not having any common node between that forward path and that particular loop, then we can say okay, this particular loop is non-touching to that particular forward path. So next we will go to find the graph determinant, that is delta. So delta can be found out as 1 minus summation of all the individual loops. So now as we know that there are three forward paths, so we will take n is equal to 3. So the Masson-Gain formula can be expanded as P1 delta 1 plus P2 delta 2 plus P3 delta 3 by delta. So now we have the values of P1 delta 1, P2 delta 2, P3 delta 3 and delta. So we will put all those values in this particular equation and we will get the final transfer function like this. So we can take another example. So again, we will follow the similar steps. First of all, we will convert this block diagram into the signal flow graph. We will point out all the nodes and then we will connect all the nodes to each other with respective gains. So like that, we can connect all the gains to individual nodes with respective gain. So this is our final signal flow graph, which we have derived from the transfer function. Now we will find out the forward paths. So in this, the first forward path is P1, that is G1, G2, G3, G4. The second forward path is P2, that is G1, G5, G4. Then we'll see for the individual loops. So in this, we'll have loop 1, L1, that is minus G2, H1. The second individual loop, we are having L2, that is minus G3, H2. And then we will check for the non-touching loops, pair of non-touching loops. So clearly from the diagram, we can see that G1, the loop 1 and loop 2 both are touching to each other. So we can say that there is no pair of non-touching loop. Then we will find out the path factors. So for the path factors, first of all, we will consider path P1. For that, we will find out delta 1. So we will see out of loop 1 and loop 2, is there any loop which is non-touching to that particular path? So for delta 1, both the loops are touching to that particular forward path. So that's why delta 1 is equal to 1 minus 0. Then for delta 2, we will check. For delta 2, as you can see that loop 1 is actually non-touching to path 1. Sorry, path 2. Our path 2 is G1, G5, G4, whereas loop 1 is minus G2, H1. So the delta 2 can be written as 1 minus L1. So delta 2 will be 1 plus G2, H1. Now we will find out the graph determinant, that is delta. So delta is equal to 1 minus summation of all the individual loops, that is delta 1 plus delta 2. Now, in this particular question, we have two forward paths. So the Masson-Gain formula can be expanded as P1 delta 1 plus P2 delta 2 divided by delta. So all these values we have already calculated. So if we put all those values, we will get the transfer function like this. So likewise, we can take more examples and practice how to convert that block diagram into signal flow graph and how to find out the transfer function of signal flow graph by applying the Masson-Gale formula. Thank you for your attention.